artificial intelligence. It's probably one of the most powerful and, let's be honest, misunderstood technologies of our time. So today, we're gonna demystify it. So let's just start with the weight of this whole conversation. When a guy like Elon Musk issues a warning this stark, you know the stakes are incredibly high. AI is a field that's defined by both this amazing promise and, well, a kind of existential dread. But look, for most of us, AI isn't really the stuff of science fiction, at least not yet. We imagine these self-aware robots, right? Think Ultron from the Avengers taking over the world. But the AI we actually use every single day, it's practically invisible. It's just seamlessly woven into our lives, powering the tools we can't live without.
Okay, so to get past all the hype, and frankly the fear, we really need to understand what AI actually is at its core. You know, the term artificial intelligence was actually coined way back in 1956 at the Dartmouth conference. And the goal they set out with was simple, but honestly, pretty profound. Could we build machines that can think and act on their own, just like a person?
So what does it even mean for a machine to be intelligent? Well, it really boils down to three key things. First, it has to adapt to new situations. This is called generalized learning. So it's like, if it learns to recognize a cat, it can use that knowledge to figure out what a lion is. Second, it needs to be able to reason, to look at a situation and decide the best thing to do. And finally, it has to be able to take in information and use it to solve problems.
All right, but here's the thing, not all AI is created equal. The whole field is usually broken down into 3 different stages, and each one is a huge leap forward from the one before it.
So this first type is basically all the AI we have today. We call it weak AI, but don't let the name fool you. It's not weak because it's bad, it's weak because it's narrow. A perfect example is AlphaGo. It's a grandmaster at the game Go, but it would be totally lost if you tried to make it play chess. Or think about your Alexa or Siri. It's great at playing a song or giving you the weather, but try asking it something it wasn't trained for, it just can't do it. It's a master of one specific thing, and that's it. Now, this is the next big step, what we call strong AI. Artificial General Intelligence, or AGI, is still theoretical, but it's the point where a machine would have the same kind of smarts as a human. It could learn, reason, create, all with the same kind of flexibility you and I have. This is the stage that really worried people like Stephen Hawking. He warned that an AGI could start improving itself over and over, getting smarter and smarter, and leaving us way behind. And that idea leads us directly to the final stage, artificial superintelligence. This is that sci-fi idea we talked about at the beginning. We're talking about an AI whose intelligence isn't just equal to ours, but vastly, unimaginably superior. An ASI could, in theory, solve problems that are completely beyond what any human mind could ever tackle. And yeah, this is the future that's both super exciting and, for a lot of people, pretty terrifying. So that all sounds pretty wild, right? But how do we even get from here to there? How does a machine actually learn anything? Let's take a quick peek under the hood. Okay, it's really important to get how these different terms fit together because you hear them all the time. Think of it like a set of Russian nesting dolls. The biggest doll is artificial intelligence. That's the whole broad idea. Inside that, you have machine learning. That's a specific way to create AI, mainly by having the machine learn from tons of data. And then, inside that, you've got deep learning. That's a super powerful type of machine learning that uses something called neural networks, which are actually inspired by the structure of our own brains. So how does this learning actually work? Well, there are basically 3 main flavors. First, there's supervised learning. This is like giving the machine flashcards with the answers already on them. You show it thousands of pictures that are labeled cat, so it learns what a cat looks like. Then you've got unsupervised learning. Here, you just dump a huge pile of data on it with no labels, and it has to find the patterns all on its own. And last, there's reinforcement learning. This is learning by trial and error. Think of a robot trying to climb a wall. It gets rewarded for getting higher and learns from its mistakes when it falls. And look, all of this stuff isn't just theory or something happening in a futuristic lab. It's already out there, in the real world, and it's having a massive impact on pretty much every industry you can think of. I mean, just think about the speed and scale we're talking about. In the world of finance, JP Morgan has an AI that can analyze 12,000 legal agreements in just a few seconds. For a team of human lawyers, that same job would take, get this, 36,000 hours. It's just mind-boggling. And in healthcare, the impact is literally saving lives. You've probably heard of IBM's Watson. It sifted through 20 million oncology records to correctly diagnose a super rare form of leukemia that had doctors completely stumped. That's just an incredible demonstration of how AI can see patterns that we just can't.
Or what about social media? AI is on the front lines of keeping platforms safe. Twitter's AI systems found and banned over 300,000 accounts linked to terrorism. And the amazing part? 95% of those were flagged by the AI before any human even saw them.
So the big takeaway here is that AI isn't some niche thing anymore. It's the engine running our self-driving cars, it's the voice of Siri and Alexa, it's the Face ID that unlocks your phone, and it's the magic that predicts what you're about to type into Google. It's just everywhere. Okay, so where is all this headed? What's the potential end game here for AI? Right now, today, we are firmly in the age of narrow AI. But some futurists, like Ray Kurzweil, they predict a moment called the singularity. That's the theoretical point in time when machine intelligence becomes just as powerful as human intelligence. And he predicts this could happen around the year 2045. And if he's right, that's the moment when everything could change.
And that really brings us to the ultimate question, doesn't it? As we keep building these smarter and smarter systems, are we creating our greatest partner, the tool that will solve humanity's biggest problems? Or are we creating our final invention, walking down a path we can't turn back from? The truth is, the answer isn't written yet. It's a future that all of us are building, one line of code at a time.
Share your thoughts in the comments. I'd love to read them. And subscribe if you want to keep exploring ideas like this.